Hello, in this video I'm going to show you how to create an audiovisual slicer. A max patch that takes a buffer and takes a video file and slices them into equal parts where you can cycle through those parts randomly or pseudo-randomly to create some nice beat slicing effects. Doing this is actually relatively easy. You do not need to know a lot of complicated max objects and commands, but we do have to think of a specific algorithm to make this possible. Let's see how this is done. Here is what I have to do. I need to create a buffer, I need to load a file into this buffer, I need to get information about this buffer and then use this information to slice my buffer into, let's say, 5 or 10 or 10,000 different parts, which I can then play, hopefully, using certain objects. So I will start by creating my buffer tilde. I will give it an arbitrary name like buff, and then I'm going to give it a file name, the file to read from. I'm going to type in jongli.aif, which should come with every Max MSP installation. Right, if I lock this patch and double click it, I can actually see the waveform, but a better way of doing this would be to use the waveform object, waveform tilde, and then the attributes buffer name, and then buff, the name of my buffer. All right, so far so good, but how do we get information about this buffer? More specifically, I need to know the length of this buffer in milliseconds, and I don't think I can do this by using these two objects. I will need a third object called info or info tilde, which is going to give me information about a buffer I have in my patch. So I'm just going to give it as an argument the name of my buffer. And you'll see that it is an intimidating object because it has a bunch of outlets. But in fact, we only need one of these, which is the third to last, or 1, 2, 3, 4, 5, 6, 7th outlet, the total time. Info is going to send information about the buffer once it receives a bang. Right, and in future videos, I'll probably go more into detail on what these other outlets do, but let's focus on this total time for now. So if I now lock my patch and click this, okay, I now know that this buffer is 2821 point something milliseconds long, which means I can actually start building my sample slicing algorithm. All right, let's do a very important operation and let's divide the total length of this buffer by an arbitrary amount. So for this, I'm going to create an integer number box, right? This is going to be the amount of slices. So if I divide this number, the total length of the buffer in milliseconds by, let's say, 1, then I'm going to get that number. If I divide it by 5, then I'm going to get 1/5 of the total length, and so on and so on. I can just use a division object, and then I just have to type 1 dot to make sure it works with floating numbers and that it will output floating numbers regardless of an integer number going in to the second inlet. So let's say give it 3, and then I click bang to trigger the operation, and now I have a very valuable piece of information. This 940 dot something is, first of all, the length of a slice if I slice my buffer into 3 equal parts. Each slice is going to be this many milliseconds long. And this will of course change if I change the amount of slices, right? If I have 5 slices, then of course this value is going to be less. The slices themselves are going to be a bit shorter. But more importantly, or at least equally importantly, this value, this millisecond, is the offset we need to add to find our start point. Let me explain it like this. If I have an integer number box, a second integer number box, that is going to be our slice position, right? Or let's call it slice index. And this is from which slice I want to start playing. As in, do I want to play the first slice, or the second slice, or the third slice, or the 5th slice? And I can't, in this situation, play the 6th slice because it does not exist. I have 5 slices. So I'm going to use a zero index system here, as in 0 is going to mean the first slice, 1 is going to mean the second, third is going to mean the, no, 1 is going to mean the second, yes, 2, so slice index 2 is going to mean the third slice, and 3 3 is going to be the fourth one, 4 is going to be the fifth one, and 5 would have been the sixth one if we had more slices in our buffer. Now, why am I doing this? Am I doing this because computer scientists are strange people? No, I'm actually going to use the slice index that is starting from 0 in my calculations. What I need to do is to multiply this value, which is the length of a slice if we have this many slices in our buffer, by my slice index. This operation is going to give me the starting point. So multiply, and by default, let's make it 0 dot so that it's a floating number again. And let's see what this spits out. So let's say 3, and then slice index 1, so the second slice of the possible 3 slices. And I'm going to get this value, 940.6 something 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 something. So this should be my starting point if I'm going to start reading this buffer from a specific slice index. So start point in milliseconds. And finding my endpoint is really easy. I just need to take this and I need to add the length of a slice, which seems to be equal to this because of course it's slice index number 1. Let's make it 2 for some visual variation. So this is my starting point for slice index number 2, aka the third slice in my buffer. And it's going to start exactly at this point in milliseconds, and it should last 940 point something 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 milliseconds. So to find my endpoint, I just need to take this value and I need to add it to my start point. So plus, again, I'm using 0 dot as an argument, so we deal with floating numbers as we're doing our maths, and I can just connect it like this. Though I don't like the way this looks, so I'm going to use a send object. So s slice time, and then r slice time. There we go. And finally, I have created this strange algorithm that gives me a lot of information about my slicing procedure. So now I have 3 slices in my buffer, and if I read the slide index number 2, aka the third slice, well, my start point is this 1881 point something something something, and my end point is this. I can actually send these values to my waveform object to visualize them in this graphical representation of the buffer. Let's use send and receive objects for these as well. So s start ms and then s and ms. These are going to be our start and end positions as floating point numbers. And of course, their corresponding receive pairs are going to be r start ms and r and ms. Now here's the thing, the third and fourth inlets of waveform are going to be receiving floating point numbers as the selection start and selection end points defined in milliseconds, which means that if I do this, and then I send a bank, I'm actually highlighting the part of the buffer that is going to be played, which is actually really, really, really cool, right? So I can change the slice index, so let's say 0, and click this button again, and there I'm targeting slice number 0. I can have 15 equal slices in my buffer and then target slice index 4, and there we go. This is what I need to be playing to hear that slice. This is all good, and we have been visualizing these slices, but of course it's not sample slicing if we don't actually play them. And to play these slices, I'm going to use, well, the play objects. There are other objects that will play the contents of a buffer like index and like groove, but for this specific purpose I want to use play. Play needs one argument that is obligatory, which is the name of the buffer it's going to read from, and an optional second argument for the number of output channels. In this case, I just want to have a single output channel. The second outlet of play will just send a bank when playback is done. So I can plug that into a live.gain object to change the gain of the audio if I need to. And for good measure, and this is something I always try to do, I'm going to create a limit tilde with the argument 2. So this is going to be a 2-channel look ahead peak limiter. And the result can go into our old friend EasyDAG. If I don't give any extra arguments to play, and if I just use a toggle with play, I can just turn on my audio, I can lower the gain a bit, and I can toggle this on to play through the entire buffer. Alright, so my selection has no meaning here. But play tilde has a specific syntax for playing just a very specific slice of the buffer. And this is something we can see in the reference to as well, is start. Start, when it's being followed by a start and an end time, is just going to play that specific section of the buffer, right? So the syntax is start, then start point in milliseconds, and then end point in milliseconds. If I send this message to my play buff, then it is going to play that slice. Now, this is really important. Start, let's say, for example, for the purposes of a demonstration, 150 to 480. If I send this message, I'm playing the milliseconds between 150 and 480. I'm starting at the 150th millisecond in my buffer, and I'm playing until millisecond number 480. But I think it would be more useful to actually format this message instead of just typing it each time. So I'm going to use pack with a C, because I want to trigger the message once I have received both pieces of information that I need. So pack, start, and then by default, let's make these 0 and 0. All right, and I have already actually sent my start and end positions, or my start and end points in milliseconds, so I can just copy these receive pairs, right? Start MS and end MS, and I can just plug these into the second and third outlets of my pack start object. But again, we have to be mindful of the signal flow here. So what I want is that it receives the end milliseconds, then it receives the start milliseconds, and only after that, this first inlet receives a bank. Right? And so right now, what is happening? Well, this data flow takes place. I receive my start point in milliseconds, which gets sent here. I receive my end point in milliseconds, which gets sent here. And after this, I want my bank. And there are a few ways of doing this, but here's what I'm going to do. I'm going to take my initial bank that is going to trigger this calculation, and I am going to use TBB. What this will do is, this is a trigger object. T stands for trigger. Is first going to send out a bank from the rightmost inlet, and once that chain of operations has been completed, right? So once everything that bank triggers has been done, then this object is going to send a second bank from its first inlet. And that we can, let's say, send play start. We can use yet another send receive pair. So send play start, and we can receive this here, receive play start, and that can go into our pack start object. And this should let us hear the slice. And if I change the slice index to 5, there we go, or 6, I can just play the different indices in my slice. Of course, again, clicking this button over and over again is pretty fun. I'm not going to lie, and we can automate this, but I think it would be cool if I hear the results as soon as I change the slice index, which means I'm going to use yet another send and receive pair. So this ended up being a send receive tutorial, and I'm going to receive play bank, right? So receive play bank, which is going to make this play, and when I change the slice index, I'm going to send play bank. One thing I have to be mindful here is, again, the message flow. When I set the slice index here, I wanted to set the value here and then start this whole process. The way it is now, play bank is to the right. Max does things from right to left. So when I do this, it is first going to play it and then register the change in my slice index. So to make this work, I should make sure that my play bang object, or splayBang object, is to the left. And now I should be able to just go through these slices. Or I can go backwards. I can change the amount of slices. So let's say 4, for instance. Or 16, anything really. And I can play through them, which is great. But again, I want to take this further and I want this to be an automated system. And this is a great chance to use randomization, for instance. Why don't I make it so I have a random object, and let's say by default this has 16, just like our current amount of slices. And each time random receives a bank, it is going to give me a random integer between 0 and up to 16. So between 0 and 15, which corresponds perfectly with my 0-based slice index system. All random needs is a bank, and well, this second outlet of play will send a bank when playback reaches destination. So I can do some clever routing and do something like this. Right, so now when play finishes playing a slice, it sends a bank to random, which is going to pick a new slice index, which is then going to play, after which play is going to select yet another random slice starting from this bank. Let's see if this actually works. I think this sounds really cool. But in this system, we have no way of stopping this naturally. To be able to stop this, I would need to delete this patch cable so there is no bank being sent. So maybe we can also use a gate. Right, what does gate do? So I can give gate, let's say, no arguments, and gate is going to receive a message from its right inlet or into its right inlet, and it's only going to send it out if the first inlet receives a 1. If the first inlet receives a 1, we can also visualize this by using a toggle. The gate will be open, which means whatever comes in here will pass through. If it's closed, then this will not happen. Nothing will come out of this outlet. So again, I'm going to route this bank here, but this time there will be a gate here. So right now, if I play this button, it will just play once and this bank will not go through. But if I turn on this toggle, I can actually stop this by turning the toggle off. Great, we have created a sample/buffer slicer, but we need one more thing, which is video. And right now I'm going to very quickly explain to you how you can do this by using video. And let's use one of the built-in videos that come with Max MSP. I'm just going to use blading. So I'm going to the left tab here, I'm choosing the video option, and I'm going to drag, if I can actually manage to drag things, I'm going to drag and drop this video, which is something I need to do when my patcher is unlocked. There we go. I've dragged and dropped this video. If I right click this, I'll see that this is a JIT playlist object. So I can visualize this by using jit.pwindow in my patch. Right, I can make this a bit bigger, lock the patch, and play this. Very important to turn the audio off, so I can right click the inlet, choose vol, and then choose 0. So I'm not hearing any audio that is associated with this video. I'm only interested in the pretty pixels with a bunch of different color values. Right, and here is some random kid roller skating, really early 2000 style with some low quality video. And I want to be able to scrub through this video at the same rate I'm scrubbing through this buffer. I want these to go hand in hand. And turns out this JIT playlist object is a bit easier to work with in this regard, as in the reference it has a specific message it can receive called selection. Right, let's clear these. There we go. Okay, so again, I need to create a very specific message that starts with selection and then start and end points. However, this time the start point is not in milliseconds, but it's a value between 0 and 1, and the same thing goes for the end point. What does this mean? Well, this means normalized values, as in 0 refers to the beginning of the video, 1 refers to the end of the video, no matter the length of the video. This can be Lord of the Rings trilogy, the enhanced edition, or this can be this 10-second footage of this random kid rollerblading. It does not matter. 0 is the beginning, 1 is the end, and everything in between is everything in between. So let's do the same thing. Pack selection 0, 0. Right, we can send this value here. One thing we need to be careful of is to actually trigger the JIT playlist object after we send this message by sending it the value 1. So I'm going to again use trigger, and I'm going to type 1 and L. L stands for list. That is the entire message pack selection 00 is going to send, and 1 is the message 1. And sending JIT playlist 1 is going to play the first video in this playlist, in this case our only video. And just for the purposes of showing you what this does, let's do it like this. Let's say I want to start from the middle of the video and I want to play until 0.8. And if I bang this, there we go. There is that slice. But of course, now we are running into a problem. This buffer is sending me all this information in milliseconds relative to the length of the buffer, right? And I need to normalize this. So I need to think a bit mathematically and think of some additions, some multiplications, and some divisions in order to reach into a range that is between 0 and 1. And I need 3 pieces of information. First of all, I need my start and end positions in this buffer, right? So I'm going to again use the same receive objects, receive start ms, receive end ms, because they're going to send this information right here, the start and end points in milliseconds of my selection in the buffer. And to be able to normalize this, I need to divide these values by the total length of the buffer, which means, well, I can use yet another send receive pair, right? I can say send total ms. So send through here, and I can say receive total ms. And then I can use my division object. Again, I'm going to type in 1 point as the default argument so that this object deals with float numbers. And they both are going to be divided by the total milliseconds, which should give me the normalized coordinates, normalized values, normalized playback position, which I'm going to feed into my jit.playlist object. So let's see. Okay, so for example, I'm playing the last slice here, and that equals to for this JIT playlist to start from 0.937 until 1, aka the end of the video. So if I bang this, I will indeed play that selection in this video. All right, then all I need is to use this play start bang and also use it to trigger this selection message right here. And let's see if this actually works. Awesome. We have a really cool buffer/video slicer that work together to create this nice audiovisual slicing experience. Of course, you can use your audio, right? Anything you create, or maybe some of the other default audios and video files, or outside of Max, maybe some videos that you create or you have downloaded. In any case, the possibilities are endless here. And I hope you have fun exploring these possibilities. I hope you create really cool stuff, and I hope this video has been useful to you. Thank you for watching.